Zakira. Hi, my name is Ranjita.
Hi, my name is Archana Sri.
Hi, my name is Nora Akila.
Hello, my name is Nur Kamarina.
Hi, my name is Nurati Najwa.
Hi, my name is Fatina Bila.
And today we are here to present our topic, which is source-free RC circuit.
Hello everyone, my name is Nur Kamarina and this is my partner.
My name is Nurul Zakira.
Today we will introduce about the source-free RC circuit. So let's take a look.
To the next slide.
Let's start with the first order circuit. First order circuit is characterized by a first order differential equation. From the circuit, we should be able to derive an equation using KCL. To apply a Kirchhoff law is purely resistive circuit result in the algebraic equation. Apply the law to RC and RC. The natural response depends on the nature of the circuit alone, with no external source. In fact, the circuit has a response only because of the energy initially stored in the capacitor. From the graph, we can see when tau equal to 1, it will decay faster, but when tau equal to 2, it will decay more slower. This is because the time constant tau of a circuit is the time required for the response to decay by a factor of 36.8% of its initial value. V decays faster for small tau and slower for the large tau. The key to working with a source-free RC circuit is finding Vt equal to V naught exponent negative t per tau, where the tau is equal to Rc. The initial voltage when the time is equal to 0 is equal to the V naught across the capacitor. The time constant tau equal to Rc.
Okay, next, the condition of the switch. As we can see for this circuit, the switch is in condition open. So when the t is less than 0, the condition of the switch is closed. And when the t is bigger than 0, the condition of the switch is open. Okay, next, the condition of the switch in the circuit is enclosed. So when the t is less than 0, the switch is open, and when t is bigger than 0, the switch is closed.
My name is Martin and I'm going to explain to you about source-free RC circuit. So this is the question, and what we have to look from this question is we look at the switch. The clue is the switch here. When the switch is open and t equal to 0, first step is we write first t equal to 0, the switch is open, and will be t less than 0, the condition will be closed, and when t is bigger than 0, it will be open. And next, when we have verified the condition is when t is less than 0 and the condition is switch closed, we have to open circuit the capacitor. Here, capacitor here, we will open it, and we have to calculate using voltage divider. So we take 9 here as it is parallel with capacitor, and over 9 plus 3 times with the voltage, and we get 50 volt.
Hello, my name is Nora Akila binti Mama Azhar. I will explain when t more than 0. When t more than 0, the switch is open. So we have to find the Resistor equivalent means 9 plus 1 ohm, we get 10 ohm. And then we have to find the time constant as known as tau 2. Tau is equal resistance time capacitor. Our R equivalent times with our capacitor 20 amp equal to 0.2 second. So Vt equal to V naught exponent Vt over tau. So 15 exponent Vt over 0.2. So we get the answer 50 exponent 95 T volt. Thank you.
Let's see the first condition when t is less than 0. The switch will be closed, therefore capacitor will be open circuit to DC. We can calculate the voltage across this open circuit point using voltage divider. So we will take the resistor which is parallel to the point, which is 9 ohm, divided by 9 ohm plus 3 ohm multiply with 20 volt. We would get 15 volt across this open circuit point.
Okay guys, now for the second condition. Second condition is when the t is larger than 0. So, when the t is larger than 0, the switch is open and the capacitor is fully charged. When this condition occurs, the first loop is not longer function. So, we have to solve on the second loop. First, we have to find the R equivalent. R equivalent equal to R2 plus R3. This is because R2 and R3 are in series. So, we get 10 ohm. Then, we find time constant, which is RC. Time constant also known as tau. For R value, we get from the R equivalent 10 ohm. C, we get from the circuit 20 milli. Then we get 0.2 second. After that, we substitute the value into this final equation. Vt equal to V naught exponent negative t over tau. V naught is equal to the V when the time is 0, which is 15. Exponential negative t over 0.2. You can just leave the answer like this, but it is better if you solve the equation like this final answer. That's all.